Good evening. I am Joshua Arguedes, and for now I will going to explain what inside the ship's logbook. So as you can see, this is the ship's logbook. OOW or officer on the watch will write here the records of the various ship's particulars. So as you can see, there is a time of AM. This means that from 1 AM to the 12 noon. So here is the course, and it was divided into 3. So standard, gyro, and the steering. So the course according to standard compass at 2 AM is 215 degrees. On the gyro is 201, and on your steering is 202. So the difference between the standard compass course and the gyro course is that the standard compass was based on the magnetic north and the magnetic south, which is it has 23.5 degrees inclination with the gyro compass, which is based on the true north and true south, and it's just like this. It's based on the fully vertical, but the standard compass is something like this. It's something like a slant or whatsoever. So the steering is the ship steering, the bridge. So as you can see, there is a wind, and the wind there is a direction in the force. So the direction is the wind is coming from, means north-northwest. The wind is coming from the north-northwest, and the force is 4 in accordance with the Beaufort scale. So here is the barometer. Barometer measures the atmospheric pressure, whether there is a high pressure, which is a good weather, and a low pressure, that means that there is a bad weather. So the reading is 1014. This is in unit of millibars. And also this temperature of both air and water. So the air, you can get the air temperature via there is an instrument on bridge which can determine the temperature of the air. So OOW records that the air is 22, and the water is coming from the engine. So you will going to ask the engine officer what is the temperature of the water, and they will get the sample on the engine room. So there is also a gyro compass error, which is caused by the variation on the earth. So this is the example of the compass error, and it is recorded by the OOW, officer of the watch. 2 degrees east, 2 degrees east, 4 degrees east, the 6 AM. And then when we have the gyro compass error, also we have the standard compass deviation. So as we know, the standard compass is was relying on the magnetic north and magnetic south. So this is a magnet, so magnet attracts to the metal, and we know that the ship made almost all parts is metal, so it can make a deviation through to the accuracy of the standard compass. So competent officer must know the deviation of the standard compass so that he can be able to manage the accuracy of the compass, the magnetic compass. So here the OOW records are written the 3 degrees west deviation, 3 degrees west, 4 degrees east, 4 degrees west, 3 degrees, 3 degrees east. So, so that is. So here you will see the soundings. These soundings is based on the phantoms. You can be able to determine the soundings or the depth of the water by the means of echo sounder. Echo sounder is very accurate device for you to be able to measure the depth of the water. There is also other means of determining the depth of the water even without use of the echo sounder. Just use the chart and see the datum or the printed soundings. So this will be serve as your guide to determine your estimated depth of the water. So after the hour of duty or the duty of the officer of the watch, and there is already 12 noon, you must retain the latitude and longitude on the 12 noon. Your vessel course is 50 degrees through. The distance is 100 nautical miles. The total is 500 nautical miles. Length of day is 15 days. Average speed is echo speed, which is 12 knots or 12 nautical mile per hour. So this was the same from 1 p.m. to 12 midnight. So this was just the same on how you write the logbook here. So you must determine the course, standard, gyro, steering, wind, direction, force, barometer, etc. So here, so this is the remarks. Remarks is very important because for example, you make a mistake, because we know you are just a man, and when you make a mistake, you just going to underline it, and then on the beside of it, you can write the corrected version of it. But these remarks is very important because you must you must write the time and the what was your mistake that have been corrected, and then you must put on the final you must put at the end of your writing the care of, and then your position and your name. So this is the example of remarks. At 0, 0 to 100, steering manual and autopilot test done. Okay. At 0, 400, the vessel pass starboard side iceberg. So you must put the coordinates of the starboard iceberg with the latitude and longitude and the distance, which is 12 nautical miles. On the 0800, sight seas, good visibility, cloudy sky, daily checklist on taking over the watch, all found in good order. So that was the example of the remarks. So here you can see the running lights. This is the lights of the vessel. So the example of this is the masthead lights and the side lights of the vessel, which is very important when we are in the restricted visibility, so that the other vessel will determine whether we are for example, we are restricted in her ability to maneuver, constrained by her draft, not under command, we're making way or not making way, we're at anchor, etc. So it must be burning midnight to sunrise, because we know there is easily restricted visibility, sunset to midnight. So here, drinking water. This is for the engine, port bilges, cover dam, and you can see the lookouts. So we know, as per call regs rule 5, you must always have the lookouts when navigating seas. They will serve as the sight and the hearing of the vessel. So here, 0, 0, 0, 100 and 0, 400, the ABD zone. In this time, AB Jutes. So they are a able-bodied seaman, because able-bodied seaman is the one who will serve as a lookout. And here is you can see the ballast tanks, inch refrigeration cargo, and the draft of the vessel. The draft of the vessel is very important also, so that the vessel will not be run aground or will have the allowance on the squat. So upon prior to sailing, the vessel's draft forward is 9.5 and 9.88 in the after part. On the arriving, 9.46 forward and 9.9 up. So it is very crucial, the draft of the vessel. So you must be very familiarized with that, and you must be you must ensure that it is accurate and correct. So this logbook also contains the engine performance. So this is the performance of our engine. Engine is very important on vessel. Without engine, ship cannot run and cannot perform navigation. It cannot be go to point A to it cannot be go from point A to point B without the engine. Engine is the heart of the ship, so it must be maintained in good condition by the competent engine officers. So distance by engine is 231, speed by engine 14.3, average RPM, so RPM stands for revolution per minute, 55, average slip percent 7.7. Fuel consumption, or the what we call bunker, 28.1 to 0.1 tons. This was our consumed during the navigation. Fuel oil, all the bunker that we have or on hand is 668.27 tons. So here the freshwater consumed. So this was the freshwater we consumed during the navigation. There is 7 tons. And we have the remaining of 270 tons. So I've done to explain all about the ship's logbook. You must perform it accurately because this is very important on board the vessel when you are a OOW or officer on watch.